Okay, welcome to the second video in the unit testing in Java series. Alright, so you can see that in the last video we learnt about testing and the broad steps to create a unit test. In this video we're going to design a test scenario. So here is the basic steps to creating a unit test. Let me get this out of the way. And so the first step is we need to choose a requirement and something minimal, some sort of minimal requirement that we want to test. So make sure you're not just testing Java itself or how a getter or a constructor in Java. What we want to test, a valid test, is something that's testing some real functionality of the program. So it should be defined in the requirements. So let's get our requirements back from the banking system from the previous video series, and let's choose one. Okay, so how about we choose number 8? Okay, so deposit and withdraw transactions, and there's actually 2 transactions in there. We should probably fix that up and separate those out. Okay, so what we really want to test, we'll test withdraw transactions. How about that? Okay, so we'll add that in there. I'll bold it a bit so you know which things I've added to this little template of mine. Alright, so let's get those numbers back. Alright, so we're going to test the requirement customers can perform a withdraw transaction. Alright, so design is the next step. So we want to design our actual application. We can't test anything unless we have some sort of API or some method design that we're going to test. So we're not going to implement this test first. In TDD, we actually do the test before we implement the methods, but we still have to design the signatures of those methods. So it could be one method or it could be a few methods, and we may need some query methods in order to implement our test. Now what usually happens is that we'll often usually have one method that we're testing, and we may have 1 or 2 other methods that are really just query methods to get the results so we can prove that it worked or not. Alright, so let's think about how we're going to design this. So we're talking about the requirement for withdrawing is really about making sure our balance is updated. Okay, so what we probably want to do is have an account class, and we want to be able to get the balance, and that'll return a double. Okay, let's bold that. Now obviously we need to withdraw, so we'll need a withdraw method, and we have to say how much we're going to withdraw. So we'll need another double in there. So we'll have some withdrawal amount, and hopefully our balance will be updated. That's what we'll be wanting to test. Now notice that of the command query separation here. So a command is something like a withdraw method that changes the state of the system. That's a command. And get balance is an example of a query method. It doesn't change the state of the system. It's purely a method that gives you some information but doesn't make any changes, doesn't mutate the state of the system. Okay, so it's a good idea to keep those separate so you can use your query methods to gather actual results and assert about them. Alright, so they're our main 2 methods, but we also need to create an account, so we'll need some sort of a constructor for that account, and we need some sort of initial balance so that we can figure out if our balance is correct. So we'll just make up a useful constructor. Got to put in the colon. Okay, so that's probably a useful constructor. It starts off with an initial balance, and we can withdraw an amount. Alright, so that's our design for our application complete. Now we're not going to implement that yet. we're going to write our test first. So when we design a test scenario, there's three parts. There's the action that's going to happen, and this is the method that the method that is under test, the thing that we're testing. So what we're testing, obviously, is the withdraw method. Okay, and so we're not actually writing JUnit code or Java code yet. We're just designing, and this is not Java code. This is sort of UML style pseudocode, and we're just going to design our scenario. So we've got our action is withdraw. Now we need some to design our fixtures. Now what fixtures are the state of the system before we run our test. So this is the state of would be the state of the account object, or any other objects that are related to account, perhaps customer, whatever's there. So the system is in some state and we want to set up that state. That's called a fixture. There's some other fixtures or inputs that are the arguments we're going to pass into the methods that we call. So we need to define those as well. So there's two things there. All right, so for the state of the system, there is going to be, we're going to assume that an account exists. Okay, that's pretty important. Okay, we need an account, and we have to make an assumption about what its balance is going to be. So let's say its initial balance is $100. Okay, so we're designing specific values. We're going to have a specific account object, and we're going to have a specific balance of $100. So when you design a test, you have to have specific constant values in your mind. All right, so that's pretty much it for the state of the system. We're just going to have one account object with a balance of $100. And now the input parameters. So our action is withdraw. So we do have a parameter, and that's the amount we're going to withdraw. So we have to define what that is going to be in our test. So let's say we take away $30. Okay, so we're going to say we're going to withdraw $30. And okay, so we've done the action, we've done the fixtures, now the results. So what do we expect the results to be? There's two kinds of results. There's the state of the system may change, and there's also return values from the method we call. Okay, so how do we expect the system to change? Well, we expect the account to still be there, but we expect its balance to be changed. So the expected balance is 100 take 30, $70. So that's what we expect to happen. We expect that account object to have $70 in it afterwards. Okay, now what about the return values? Okay, so withdraw doesn't have a return value, and the get balance does. All right, but that's part of our query method. It's not what's under test. Okay, so that's not really applicable at the moment. But we expect the call to succeed. So in other words, it doesn't throw an exception. So in JUnit, you can actually specify that your call does throw an exception. So in this case, we don't want to do that. All right, so that's pretty much a test scenario with specific constant values and our expected results all designed. All right, so in the next video, we are going to convert this scenario into a JUnit test case using Java. All right, thank you.